I feel the same way. I mean, I just don't want to spend time and...
In this sequence, I'm talking to a group of students who've just completed their home experiment in which they've measured the percentage of water in a potato. The values they've come up with are all rather different.
For the amount of water?
79%. Well, I did the experiment as well. Used a conventional oven, scales pretty much like these ones, which could read to about half an ounce. I was actually using ounces, I'm afraid, old-fashioned units. No particular problems. I ended up with a value of 77%. So you see, we've got quite a range of values here from 68 up to 79. Are you surprised that we don't all get the same answer?
Well, I suppose we all use different kinds of scales and we use different ovens, so it's probably not surprising that there's some variation.
Mm-hmm.
I mean, maybe we use different kinds of potatoes. Would that affect it? Or?
What do you think?
Well, I think mine probably did. Looking back, mine were very elderly potatoes and they really were quite shrivelled, so I would assume that there perhaps wasn't as much water in those as say, a new potato.
Okay, and in fact, you're the person who got the 68%, the lowest value, so
yeah.
that does correlate with them being old and shrivelled.
Mm.
Okay, but suppose you'd all had identical potatoes, if you could actually produce identical potatoes. Do you think that you would have been able to get pretty similar results then?
Not really. I mean, we were all using different ovens, different scales. I mean, I suppose you wouldn't expect them all to come out quite the same, would you?
No. Okay. It'd probably be worth having a look at these scales and the uncertainties associated with measurements there. Why don't you show us how yours operate, Annie?
Okay. Well, they're just electronic scales. If I try this weight on them. And that reads 116 grams for that one.
Okay, so that's reading to the nearest gram.
Mm-hmm.
That's pretty good. Why don't you try it on the scales in the middle, Pete?
Well, I think we have to line this up first.
Are you zeroing it?
Yeah.
Okay.
So that now reads halfway between 100 and 125.
Okay. Try it again, see what you get.
Oh no, that's definitely 125.
Right, and a third time? And what's determining how accurately you can read that?
Well, that is near 100. I don't know, the needle is quite thick, but depending on how you line it up, you can actually almost move up a division.
I suppose it also shows how much difference there is between the scales, because Pete's reading of 125 is 10 grams higher than mine.
Yes, yes. So all of these things essentially are giving some uncertainty in the measurements you make of the mass. Mm-hmm. You can't be sure precisely what the mass is. There's an uncertainty there. So I think we've identified 3 different things that could contribute to that uncertainty. What were those 3 things?
We talked about different sorts of potatoes.
Okay, so we got...
They'd be different.
Yeah, so there's a variability there, and that's common to lots of sort of biological specimens or living examples. I mean, the percentage of fat in people varies, and the percentage of water in potato varies, so there's an uncertainty there. What else?
Well, the scale's accuracy.
Right, okay, so the scale itself. What was the third thing?
Well, I would assume it's the way you actually read the scale. I mean, presumably you can read the scale different ways, from the left, from the right. So you've got really to read it the same way every time.
Yeah, right. With some of these scales, you can only read those to about half an ounce or 10 grams or something like that. Right, okay.
What about the kind of mistake I made where I forgot to add the weight of the placemat in and then had to add it in later? Is that uncertainty as well?
I wouldn't call that an uncertainty. I'd say that was a mistake, as you say, or an error. I mean, the difference is that with the reading of the scale, I mean, you can't do it better than a certain uncertainty. Whereas if you know what your mistake is, you can put it right. And then get an answer at the end of the day that doesn't depend on that.
So an uncertainty is something you can't avoid to some extent.
Yes.
Right.
Yes. Well, we've talked about the various uncertainties in the experiment. Did any of you have any particular difficulties with the way you carried out the experiment or the planning of the experiment?
Yes. Well, I thought I had planned it very well, But it turned out that people were coming around on the Saturday afternoon, so I had to stop the experiment in the middle of it, turn the oven off, and restart the whole thing about 2 hours later. So, yes, that was a difficulty which I should have overseen.
Okay, it probably didn't matter in this experiment, but if you're doing a different sort of experiment, it could have sort of aborted it completely, presumably.
Yes.
Anything else?
I had a bit of a problem cutting the potatoes fine enough. I don't have a very good knife, so I didn't get them down to the 1 millimetre it suggests in the book. And they did actually take quite a long time to dry out. I mean, it took half an hour to do it in a microwave, which is longer than it suggests it might do. So perhaps if I'd cut them finer, it would have been quicker.
Mm-hmm.
And perhaps they didn't dry out fully because of that.
Yeah, certainly would have been quicker. Whether you got a different result, difficult to tell.
Well, the weight was still going down even when it got to within 20 grams.
Ah, okay.
You know, it was.
Right.
I guess if I'd carried on going, it would have kept going down. So perhaps I would have got a higher percentage of water for the potatoes.
Okay. What about you, Pete?
Well, it wasn't so much a problem, but in trying to cut the millimetre slices, I was taking my time doing it, and it did cross my mind that as these slices were laying around before I started the experiment, they may have been losing moisture. Now, I didn't know whether I should have done away with the millimetre and gone a bit quicker and had some 2, some 1/2 or whatever.
Okay, well, that could have also partly explained your low value for the percentage, 68%, because if you'd lost some water before you first measured the mass, then that would end up with a lower percentage, I think.
Yeah.
Okay, now, having done the experiment, it's always good to go back and sort of think about it critically, and in particular, sort of think what you might have done different if you had to do the experiment again, or what you could do to improve the experiment if you wanted a better result. You got any ideas about that?
Yes, the first thing I would have done would be to plan better my afternoon so that I didn't have to stop the experiment in the middle. And also I probably would have got hold of better scales, to avoid a lot of uncertainty in my value. Yeah.
I obviously would have used fresher material, knowing what I know now, but the experiment was fine.
Mm-hmm. And I guess that for some of you, the scales was a limiting factor, wasn't it? If you wanted a more accurate value, you probably would have liked to have borrowed Annie's electronic scales, but that doesn't really matter.
Yes.
I was really quite pleased that I actually managed to do this and get a 79% value, which seemed like quite a good result.
Yes.
And do an experiment like this just in the kitchen with stuff I had anyway. It was quite surprising that. I mean, I didn't think it was going to be worth doing, and then I did it, and it was really surprising the result I got.
Okay.
So.
Well, I think what that shows is, a scientific experiment isn't something necessarily done by white-coated people in labs. It's the sort of method that you use, the planning, the measurements, the assessment of uncertainties and things like that, that are the important thing about doing a scientific experiment.